consider subscribing so that when I'm going to upload more tutorials, you'll be notified. If you have not watched the masterclass of physics practical, check in the description so that you can be able to see how you are supposed to approach all questions of paper 3. So let's start. The first question the question that you are going to see there, one of the questions that you are going to see in that paper is where you are supposed to work out the percentage uncertainty of a measurement. In this case, we are supposed to find the percentage uncertainty of L. So if L is a measurement that you have taken and you're supposed to find the percentage uncertainty, you need to use this approach. I want you to go back. You need to go back and take different measurement for L. So you can measure again L, maybe you will get 5.6. Again, you repeat taking that measurement, you get 5.5. And again, maybe you can take the measurement, you get 5.8. So you repeat different measurements for that L that you are being told so that you can be able to get different measurements. Then the first thing you are going to do is to find the mean of L. Mean of L. And the mean is 5.6 plus 5.5 plus 5.8 divide by the 3 that you have there. So if you work out the mean, let's just work it out together so that we can see what are you going to get at that given point. So if you are going to be asked that question, first thing to do, whenever you are asked to find the percentage uncertainty, repeat that measurement they have told you so that you can be able to get the 3 different measurements, so that we can say this 5.5, 5.6 plus 5.5 plus 5.8. I'm getting 16.9. 16.9. You can see this value that I'm getting here, 16.9. Yes. So divide by 3. My mean is going to be equals to 5.6. This is my mean for these values that I've gotten here for L. That's the mean. The next thing we are going to do here is to work out the range. And range is going to be the largest number minus the smallest number. So the largest number here is 5.8. The smallest is 5.5. So the range would be 5.8 minus 5.5. I'm going to get 0.3. So how will you work out the uncertainty? Uncertainty is equal to a half the range, which is going to be what? Which is going to be equivalent to a half of the range. The range here, a half of this range, we're going to get uncertainty is going to be equal to, you divide this by 2, this is going to be 0.15. That is the uncertainty for this L. So once you have the uncertainty, you are going to say now uncertainty, which is 0.15 over the mean that you had gotten, which is 5.6 times 100. And if we work it out, let's see what is going to give us. 0.15 divided by 5.6 times 100. This is going to give us 2.7. 2.7. So your percentage uncertainty is 2.7%. 2.7%. So basically, if you are asked that question, of course you will be asked that question of finding the uncertainty of any given measurement. What you are supposed to do is to repeat that measurement, get different measurements, find the mean, and also find the range. Range is the largest minus the smallest, and using the range, divide it by 2 to get the uncertainty. Then from there you can be able to apply uncertainty over the mean times 100 is going to give you the percentage uncertainty. So that's how you will score that mark for uncertainty in this given point. The second mark is justify the number of significant figures. For instance, they are telling you to find M. You had measured L. You had measured an angle theta. So they are telling you M is equals to square